Picture this. You're trying to drive up a sand dune, but, like, you're on Mars.
Oh, and your car is a billion-dollar Rover.
Uh-huh, exactly.
Mm-hmm.
That's what Perseverance is dealing with right now, climbing this super steep crater rim.
It's wild, right?
Totally. So we're diving into this NASA news release. NASA's Perseverance Mars rover navigates Jezero's steep crater rim.
Just came out a couple days ago, October 22nd.
Yep. And today we're going to try to unpack why this climb is so important for finding, well, signs of ancient life.
The coolest part is how the science goals are like butting heads with the engineering challenges.
Oh, how so?
It's crazy hard terrain for Perseverance to get through, but the payoff could be huge, like groundbreaking discoveries in those rocks.
Okay, yeah, the article kept mentioning regolith. Sounded like that was the main problem. What is that exactly?
Think of it as Martian soil, but way worse.
Worse how?
It's this loose, unstable stuff, like a mix of dust, rock fragments, you name it.
Sounds like a recipe for disaster.
It kind of is, especially for a rover. This stuff has been blasted by radiation, meteorites for billions of years.
Oh, wow, yeah, that'll do it.
So picture this. Perseverance's wheels could sink in so deep it's like constantly driving uphill, even on flat ground.
No kidding. So it's not as easy as just picking a spot on a map and saying go.
Nope. There's a ton of teamwork behind the scenes to make this climb even possible.
That makes sense.
It's a constant back and forth between the science team, they want to study the cool rocks, obviously,
right,
and the engineers who are just trying to keep Perseverance from, falling apart.
Yeah, I bet. Every move has to be super calculated, then.
Oh, absolutely. One wrong move and the whole mission could be over.
No pressure, then. So, Summerland Trail, that's what they're calling the path Perseverance is taking, right?
Yep, that's it.
Where did that name come from?
So Jezero Crater's massive, right? Scientists divided it up into sections they call quadrangles.
Kind of like neighborhoods on Mars.
Exactly. And Perseverance is exploring the Mount Rainier quadrangle.
Wait, Mount Rainier? Like the one in Washington?
Yep, that's the one.
That's pretty cool, naming Martian landmarks after places on Earth.
Yeah, and it gets better. Within that quadrangle, this specific route, they named it Summerland Trail.
No way.
Because there's a real Summerland Trail on Mount Rainier. It's a popular hiking spot.
Huh, that's awesome that they did bring in a little bit of home with them.
I love that. And speaking of the journey, this climb has a destination. Pico Turquino. It's an outcrop.
Okay, why is that spot so interesting to scientists?
Well, they think Pico Turquino might have exposed layers of really, really old Martian rock.
Oh, so it's like a history book of Mars geology just waiting to be read.
You got it. And to do that reading, Perseverance has got some seriously high-tech tools.
The article mentioned PXL and Sherlock. Those names sound familiar.
Like something out of a detective novel, right?
Right. I'm picturing Sherlock Holmes with a magnifying glass on Mars.
Haha. Well, PXL basically is a high-tech magnifying glass, but instead of just looking at the surface, it uses X-rays.
To see what?
The chemical makeup of the rocks, but like on a super tiny scale.
Looking for clues to past life then.
Exactly, like maybe fossilized microbes, stuff like that.
Okay, that makes sense. And Sherlock's, what does that one do?
Sherlock is like the chemistry expert on the case. It can detect organic molecules, the building blocks of life as we know it.
So if Sherlock finds something, that's a pretty big deal.
Huge deal. And get this, it was just reactivated recently after being offline for a bit.
So the team must be really eager to see what it finds.
Oh, absolutely.
This is where my brain starts to fry a little, though. We're talking about rocks that are billions of years old, from a totally different planet. How do scientists even begin to understand what they're seeing?
That's where the idea of ancient stratigraphy comes in. Imagine a layer cake, right?
Ooh, cake. I like where this is going.
Each layer is a different time period in Mars's history.
Okay, I'm with you. So what's the frosting?
Haha. The frosting is the surface of Mars we see today, the most recent stuff.
Gotcha. So Perseverance climbing higher on the crater rim is basically cutting into that cake, exposing older and older layers.
Exactly. The crater floor is like the newest chapter, and as we go up, we go further back in time.
So the rim could hold secrets about Mars that are way older than anything on the crater floor.
Potentially, yeah. And those lower layers, formed billions of years ago, they might show us a Mars that was completely different from what we see today.
Different how?
Environments that might have been much more suitable for life. Think about it.
Okay, you've officially got me hooked. But before we get too deep into that, the article also mentioned that Perseverance isn't just gathering data at certain stops. It's constantly observing, even while driving.
Oh, yeah, that's right.
What can it see while it's on the move?
Perseverance is basically a mobile science lab. It has all these tools that let it study Mars from, like, all angles.
Like what?
Well, there's Mass Kimsey. It's like having high-definition eyes on the ground.
So a rover with giant binoculars scanning the horizon.
Pretty much. It can zoom in on things, make 3D maps, even take panoramic pictures.
So like a geologist with superhuman vision.
Haha, exactly.
Yeah.
Then there's SuperCam, which is like a laser-powered detective. It zaps rocks with a laser beam, analyzes what comes off to see what they're made of.
Wow, so not just looking at rocks, but zapping them with lasers. Why go through all that?
Well, you can learn a lot more about a rock's chemistry that way.
I guess that makes sense.
It can even use a microphone to listen to the sound of the laser hitting the rocks.
Hold on, it's listening to rocks.
Yeah.
This is amazing. What does that tell you?
It tells scientists about the rock's hardness and structure, whether it's soft or hard, porous or dense.
So Perseverance is gathering information with its ears and its eyes.
That's right.
Okay, this mission just keeps getting cooler. But why bother gathering all that data while driving? Wouldn't it be faster to just stop at specific spots?
Think about it like exploring a forest. You could just stop at certain trees and look at them closely. But you'd get a much better sense of the whole forest if you also paid attention to the light, the sounds, the different plants as you walk through it.
You're right. The more info we gather, the better. And it sounds like Perseverance is collecting data nonstop.
Oh, yeah.
Which brings up another question.
Yeah.
How does all that data actually get back to Earth?
Right. We're talking about a rover on another planet sending us info about rocks and lasers and microphones. It's like science fiction. Well, it kind of is. Perseverance has this powerful antenna that can talk directly to Earth.
Directly. No way.
Yep. But most of the data actually goes through orbiting spacecraft, kind of like signal boosters.
So it's like a game of telephone, but across millions of miles.
You could say that. And once the data reaches Earth, it goes to NASA's Deep Space Network.
And what is that?
It's a bunch of giant antennas all over the world, always listening for signals from spacecraft out in the solar system.
That's so cool. So who gets to see all this amazing data once it gets here?
NASA is pretty awesome about sharing this stuff. They put raw images and data online for anyone to see.
Wow. Seriously.
Yep. Scientists all over the world can also request more detailed data for their research.
So anyone with the internet can basically look at Mars right now, like they're standing there with Perseverance.
Pretty much.
That's incredible. And that all these scientists are working together, trying to piece together the story of Mars from this data.
Exactly. It's a massive global team effort.
So amidst all that data, what's been the most surprising discovery so far? What has everyone buzzing?
There have been tons of cool findings, but one of the biggest was detecting organic molecules in some of the rock samples.
Wait, organic molecules, as in the building blocks of life.
Yeah.
Does that mean they've found life on Mars?
Not quite. Organic molecules are important, but they can also be formed without life being involved.
Ah, so it's a clue, but not definitive truth.
Exactly. And that's why this crater rim climb is so exciting. We're on the edge of our seats, waiting to see what else Perseverance might dig up as it goes further into those ancient layers.
Well, we've covered a lot in this first part of our deep dive. We've talked about the driving challenges, the tools, the clues. It's amazing. But there's one big question I still have. Why this crater rim? Why is it so special compared to everywhere else on Mars?
That's the question that takes us back to the very beginning of this mission. Why did they choose Jezero Crater as the landing site?
Okay, now I'm really intrigued. What's so special about Jezero?
Well, picture this. Billions of years ago, Jezero wasn't a crater at all. It was a lake. A big one, fed by a river, with all the ingredients that might have made it a haven for ancient life. Imagine this huge lake, rivers flowing into it right across the Martian landscape.
Whoa, a whole Martian lake. Seriously.
That's what Jezero Crater was billions of years ago.
I mean, I knew Mars had water once, but actual lakes, that's wild.
It gets even cooler. We can still see signs of a river delta on the west side of the crater.
A delta, like the Mississippi Delta.
Exactly. Picture that, but on Mars. Water flowing in for ages, carrying sediments, depositing them in layers. Those layers could be packed with info about ancient Mars.
Okay, so water, layers. But that doesn't automatically mean life, right?
Yeah.
What else makes scientists think Jezero might have had life?
Good question. From orbit, and from what Perseverance has already found, we know Jezero's got a lot of minerals like clays and carbonates.
Okay, and those are important because...
They form in watery environments, and they're great at preserving signs of past life.
Ah, so Jezero isn't just an ancient lake bed. It's an ancient lake bed with the right stuff to have supported life and preserved evidence of it.
Exactly. It's like hitting the jackpot for scientists. And this crater rim climb, that's what makes it even more exciting.
Why is that?
Because the rocks exposed on the rim might be way older than the ones down on the crater floor. Remember the layer cake?
Oh, right, yeah. The higher we climb, the further back in time we go.
Exactly. It's like digging deeper into an archaeological site.
But how much older are we talking here? Millions of years. Billions.
Billions. With a B. The rocks on the crater floor probably formed when that lake was still there. But the rim rocks, those could be from before the lake even existed.
Whoa. So we're talking about a whole different era of Martian history then.
Exactly. The crater floor is like a snapshot of a younger, wetter Mars. The rim, that could be a glimpse of something older, maybe even drier.
And each time period could have had different kinds of life.
You got it. Imagine if we found fossilized stromatolites on the crater floor.
It'd be amazing, right?
Incredible, yeah. But it wouldn't tell us how far back life might go on Mars.
Because those stromatolites could be relatively young, geologically speaking, but finding them on the rim in those much older rocks.
That would change everything. It would suggest that life existed on Mars far earlier than we ever thought possible.
Maybe even when Mars was more like Earth.
Exactly. Okay, so before Perseverance reaches Pico Turquino, it's got this crazy terrain to get through.
Right, and it's not just about moving. It's about gathering all that data along the way. We talked about Mastcam Z before, how it gives Perseverance that superhuman vision.
Yep, those incredible eyes.
Remind me again, what does SuperCam do?
SuperCam's like having a laser-powered chemistry lab right there on the rover.
Okay, that's pretty high-tech. How does that work?
It fires a laser at rocks, vaporizes a tiny bit of them, and then analyzes the vapor to figure out what they're made of.
So it's not just looking at rocks, it's zapping them with lasers and figuring out their chemical composition.
It's pretty cool. And it gets even cooler.
Cooler? How?
SuperCam also has a microphone. It listens to the sounds of the laser hitting the rocks.
Wait, what? We've got a robot on Mars shooting lasers at rocks and then listening to them.
I know, it's amazing.
But what good is listening to a rock?
You can actually tell a lot from the sound, whether the rock's hard or soft, porous or dense.
It's like giving Perseverance another sense, like hearing, to help it understand these rocks.
Right.
This mission is mind-blowing. But we keep talking about all this data. How does it actually get back to Earth?
That's the thing, right? We've got this rover on Mars sending us info about rocks and lasers and microphones. It's like something out of Star Trek.
It really is.
Perseverance has a powerful antenna, so it can talk directly to Earth. But most of the data actually goes through orbiting spacecraft. They're like signal boosters.
Ah, so it's like a cosmic game of telephone.
Haha, kinda, yeah. Perseverance whispers to a satellite. Satellite shouts down to Earth.
Millions of miles apart. That's amazing.
Yeah.
So once that data gets here, where does it go?
It goes to NASA's Deep Space Network.
And that is?
It's this global network of giant antennas constantly listening for signals from spacecraft all over the solar system.
Okay, so we've got the data, loud and clear. But who gets to see it? Is it just NASA scientists?
NASA's really good about making this stuff public. They put raw images and data online so anyone can access it.
Wow, seriously? Anyone can see the latest pictures from Mars?
Yep. And scientists all over the world can request more detailed data for their research.
So it's this huge collaborative effort with scientists all over the globe trying to piece together the story of Mars.
That's right. It's a global team effort.
So with all that data pouring in, what's been the most surprising or unexpected thing Perseverance has found so far?
We talked about the organic molecules earlier.
Yeah. Any other big aha moments?
One that really shook things up was finding igneous rocks on the crater floor.
Igneous rocks. Okay, refresh my memory. What are those, and why is that a big deal?
Igneous rocks form from cooled magma or lava. Finding them in Jezero means the crater floor had some serious volcanic activity at some point.
Okay, so we're not just talking about sedimentary rocks, the ones formed by water and sediments. We're talking about rocks that were basically born in fire deep underground.
You got it. And that gives us a whole different window into Mars's past, a period of intense heat and pressure, probably long before that lake formed.
So evidence of a watery past, a fiery past, and maybe an even older past hiding in the crater rim. Jezero Crater's like a time machine. But amidst all this exploration, what are the big goals of Perseverance's mission? What's the ultimate purpose?
The main goal is finding signs of ancient life, absolutely. But it's also about laying the groundwork for humans to go to Mars someday.
Oh, wow. So it's not just about looking back in time, it's about the future, too. What do you mean by laying the groundwork?
Well, Perseverance has instruments that are testing technologies that could be crucial for human missions, like a maquis, for example.
On a key. What's that?
It's an experiment to see if we can produce oxygen from the Martian atmosphere.
Wait, you mean actually making breathable air on Mars?
Exactly. It's a game changer for future human explorers.
That's incredible. It really is. So Jezero Crater isn't just important for understanding life beyond Earth. It's part of our journey towards actually going to Mars.
I love that way of thinking about it. It's a huge step for humanity.
It really is.
Yeah.
With all the discoveries we've been talking about, what are the scientists most excited to find as Perseverance keeps climbing? So we've talked about ancient lakes, volcanic rocks, even the possibility of making breathable air on Mars. What's next? What are the scientists hoping to find as Perseverance keeps climbing? Like, what's the ultimate discovery they're dreaming of?
There are a few things that would be absolutely huge, like finding actual fossilized life. Those stromatolites we talked about, that would be game over.
Yeah, that'd be proof positive that life existed on Mars billions of years ago.
Mm.
But what if they're not just sitting there, easy to spot? What if the evidence is more hidden?
That's where things get really interesting. Scientists are looking for any signs of biosignatures, basically traces that could only have been made by life.
Okay, so like molecular fossils, chemical fingerprints, that kind of thing.
Exactly.
What would be some examples of biosignatures that Perseverance could actually find?
Well, one example would be finding certain types of organic molecules, the kind that are hallmarks of life.
Like what?
Say, complex organic molecules like lipids or proteins preserved in the rocks. That would be pretty compelling evidence.
So it's not just about finding any organic molecules, it's about finding the right kind of organic molecules.
You got it.
Makes sense. What else are they looking for?
Isotopic ratios.
Isotopic ratios. Gonna need you to explain that one.
Okay, so you've got two versions of the same element, like carbon. Same number of protons, but different number of neutrons.
Okay.
Those are isotopes. And life tends to prefer certain isotopes over others.
Ah, so if Perseverance finds a rock with a weird ratio of carbon isotopes, that could mean life was involved in making that rock.
Exactly. It's like finding a fingerprint at a crime scene. Not conclusive on its own, but definitely worth investigating.
Okay, now I'm seeing the bigger picture. Perseverance is climbing this crater rim, going further and further back in time with each layer of rock. And it's using all these amazing tools to analyze those rocks, hunting for any little hint of past life. It's pretty wild.
And don't forget, Perseverance isn't just collecting data, it's collecting samples, too.
Samples. You mean actual pieces of Mars?
Yep, that's right. Perseverance drills into rocks, extracts a core sample, and seals it in a tube.
And what happens to those tubes?
Eventually, they'll be brought back to Earth by another mission.
Wait, seriously, we're going to have pieces of Mars back here on Earth?
That's the plan.
Why is that so important?
Perseverance's instruments are amazing, but they can only do so much. Imagine what scientists could do with Martian samples back in labs on Earth.
Yeah, with all the best equipment and, the best minds in the world all focused on these Martian rocks.
Exactly. That could be what finally answers the question, did life ever exist on Mars?
Wow. This mission really is mind-blowing. It's so much bigger than just driving a rover around. It's like pushing the limits of what we know, searching for answers to these huge questions about, like, our place in the universe.
It's incredible, isn't it?
And thinking back to what you said about Perseverance paving the way for humans to go to Mars one day, it makes it all even more inspiring.
It's not just about exploring for the sake of exploring. It's a stepping stone to something even bigger.
Yeah, it feels like we're at the start of something truly historic.
I think so too.
Well, we've covered a lot of ground in this deep dive into Perseverance's crater climb. We've learned about the challenges, the incredible tech, and the huge implications of this mission.
It's been a fascinating journey.
What's the one thing you hope our listeners take away from this? What do you want them to remember?
I'd say this. Next time you see a picture of Mars or read about some new discovery, remember that there are real people behind it all.
A whole team of brilliant, dedicated people working their hearts out to solve the mysteries of Mars.
Absolutely.
And that every piece of data, every image, every sample is bringing us closer to understanding whether or not we're alone in this vast universe. Thanks for joining us on this deep dive into Perseverance's incredible adventure. Until next time, keep looking up and keep exploring.